Assalamu alaikum. Ali, can you hear me?
Walaikum assalam, I can hear you.
Okay, Ali, did you make any revision for kinematics?
Yes, that is what I was doing right now. Like I was solving a paper that had a lot of kinematics questions. So that is
Ah,
why I got.
that's good, now. Because remember the plan was there that we didn't work out mechanics in our tuition. We covered electricity, we covered nuclear, we covered waves, we did questions on them. But in mechanics, there is a very important pair of chapters, kinematics and dynamics. They are very important. They come every year, and this is a very powerful source of marks in paper. So if you have your paper one book with you, can you bring it? The
They are
paper
from
one.
2016 onwards.
Acha, you told me right. Okay, then it's one. You can see on the screen the velocity of an electric car changes as shown. What is the acceleration of the car? When you talk about acceleration, it is the gradient.
Of the velocity time graph.
Yes, it's a velocity time graph, and it is the
The
gradient,
great.
and gradient is always y upon x. You always have to carefully see whenever you are working out for gradient, the graph is starting from origin 0, 0 or not. So you can take 1.00, and second point you can take 4, and you can take this number. It should be 105.
By this, it comes as 26.25.
Acha. You use the 105 minus 0 upon. It's only one box, right? It's one box.
So C will be the answer for this.
Looks to be. You said 26 point.
25.
This working definitely shows C. A science museum designs an experiment to show the fall of a feather in a vertical glass vacuum tube. Vacuum means no no air resistance. So it means when he says vacuum, acceleration is equal to G. The time of fall from rest is to be close to 0.6, 0.5 second. So this is T, this is U is equal to 0. I'm trying this equation because it's asking for length of the tube. Initial velocity is 0.
Can we just multiply 9.81 with 0.5?
But it should be a square now. You can obviously my working is not required like that, but it's good to do working here.
This gives the answer as 1.226.
Can you repeat 2 point?
1.226. Can I just have 1 minute? I'm coming.
Uh-huh. No problem.
I've come back. It was actually raining a lot right now. It's actually raining, so that is why I had to go.
Oh, is it raining in Lahore?
Yes, it's raining a lot right now.
Oh, that's good. That's very good. And now, can we discuss now question number 10? Our answer in rounded form is coming to be,
A 1.3.
yes. A bicycle brakes so that it undergoes uniform deceleration from a speed of 8. This is U, this is V over a distance of this. If the deceleration of the bicycle remains constant, what further distance will it travel before coming to rest? Acha. This is a bit tricky question. He says that bicycle brakes so that it undergoes uniform deceleration from speed of 8 to 6 over a distance of 7. If the deceleration of the bicycle remains constant, what further distance will it travel before coming to rest? It means rest means speed is equal to 0. Now, we can do one thing. We can first try to find the acceleration, which will, he says, constant.
But we don't have the S. We'll take S as 7 for this acceleration.
Because acceleration won't change. He has used the word deceleration. So I will not use the, I will not put negative with the answer. Once I get the acceleration, I will go for the second line, further distance.
Is 2 meters per second.
Hmm.
It's coming as 2 meters per second.
So this is a retardation. So now I will make another data. For the first patch of the journey, velocity has dropped to 6. So let's take the 6 as the start. He says rest. Notice that for calculation purpose, I am taking again the negative value.
By this, it is coming as 9 meters.
That looks fine. A ball is thrown vertically in air, neglecting air resistance. Which property of the ball can never be zero at any time during the flight? Acceleration. The ball is thrown upward and it must be going up. It will stop at the highest point and then it will come back. It will stop at the highest point. When it will stop at the highest point, its kinetic energy will be zero. Speed will also be zero. Now, two options are left.
So isn't the velocity also zero at the highest point?
Right. Velocity is no, velocity is not zero because object is taking a U-turn. The problem is he's using the word never. When the ball will come down,
So acceleration will never be zero.
yes, acceleration will never be zero. Because at the highest point here, acceleration will be maximum.
That will be the downwards acceleration then.
It will be a maximum acceleration at the turning point. Now, this is a famous question in many times. The graph of velocity against time for an object moving in a straight line as shown. It's a velocity time sketch. Object accelerates, constant acceleration, then zero acceleration, and then retardation. What is the corresponding graph of displacement against time? This is where sketches must be known. For the first part, let's first work out this sketch if I label it. For the first part, OA, constant acceleration, velocity increases. Here, velocity becomes constant, velocity decreases. Now, which graph suits us where velocity, first velocity, this displacement time graph, in a displacement time graph, gradient is speed. In a displacement time graph, gradient is velocity or speed. So first velocity increases, then gradient becomes constant, and then velocity decreases. Remember that displacement time graph, gradient is velocity. Velocity is not negative anywhere.
A will be the answer for this.
The first part means velocity increases. That's right. Second part means velocity is gradient is constant, but the third part is the problem. Third part is a curve, which means gradient is increasing. This part means velocity is increasing. No, sorry, velocity is decreasing. Its gradient is getting flat. Velocity is increasing. Velocity is negative. That's a problem. Gradient is negative, but in our case, throughout the motion, velocity is positive. For the whole motion, velocity is positive. Second part, you can see B has an issue. He's showing negative displacement. If it would be a negative displacement, the object must have taken a U-turn and gone back, but the graph doesn't show, the source graph does not show a U-turn. Now C and D are the options. Let's analyze T. The first part, this part shows increasing gradient. It shows constant gradient and it shows decreasing gradient. So this shows increasing velocity. This shows constant velocity and this shows decreasing velocity. Now, what's your opinion on C?
C can be right.
Now, and for a safe side, why not D? Straight
Because
line. Straight line means when you draw a straight line, it means constant velocity. Again, constant velocity. Again, constant velocity. So C is wrong. D is wrong. This is a game of gradient. So displacement time graph, gradient is velocity. It's a straight line. So gradient would be constant. We need a changing gradient. A ball is released from rest above a horizontal surface. It bounces once and is caught. Which graph represents the variation with time of the velocity of the ball? A ball is dropped from rest. So let's drop the ball like this is a surface and the ball bounces. It bounces once and then caught. So if I take downward velocity plus, the upward velocity will be negative. It's a rebound. It's a bounce back. It means velocity should be negative. Velocity should be negative.
So D is right for this one.
Why not A on B? Why you are not taking A and B?
B doesn't show 0 from rest.
Also, A and B, do they show negative velocity?
No.
That's a good point. So A and B are out.
So rebound would also always have a negative velocity.
That's a logical, na? Because rebound means it's a change in direction. Whenever direction changes, reverses, velocity will become negative. We have option left with us, C and D.
So does D mean it bounces one and then bounces back again?
No. First, make a concept. When something is falling down, velocity should increase or decrease. When something is falling,
Velocity will decrease,
okay?
increase.
Something is falling. Think logically. When something is coming down, its velocity will increase or decrease.
It will increase.
Yes. And when something is going up,
It will decrease.
now you see, what about C? This part means velocity decreases and then velocity increases. Here, velocity increases and then velocity decreases.
If it is from the top coming from, then the velocity should increase at first.
Yes, whenever something is coming down, he says release from the rest from the above a surface. So it's coming down. So first part, the question first part should be showing increase in velocity. And the second part should be showing decrease in velocity.
D is correct.
Why not C?
Because the first part from the rest, it is showing that it is decreasing the velocity.
Yes. Now, this is a type of projectile, and I had shared some quick notes with you. Projectile is always a challenging topic. A golf ball is hit with the same force and direction on the earth and on the moon. Remember, there is no air. In actual, there is no air on moon, but on the surface of the earth, air is present. Which diagram best represents the shape of the path The two cases. Also, gravity is less on the moon. Gravity is much greater on Earth.
So D will be wrong because it shows a straight line.
Because it means that the ball will never come back. So that is right. You're perfectly right. This is wrong. Now, there should be a good, now the point is there, they always leave a track. Why A showing an abnormal shape on moon? It should not be on abnormal because, you know, this shape, it goes up and suddenly comes down. This is only possible due to air resistance. But there is no air resistance on moon. So there is no air resistance on moon. So A and B are also wrong. Why A and B are wrong?
Because of the odd shape.
Because this is air. Air can do a sudden drop. Now, what about C? Do you remember the typical projectile shape? Is it coming valid for moon?
Yes.
And there is no air resistance. But
Yes.
what about Earth? Why the shape is a bit demented?
Because of the air resistance.
Yes. Another famous question. The dotted line shows the path of a competitor in a sky jumping competition. It is like a big jump. Ignoring air resistance, which graph best represent the variation of his speed v with the horizontal distance covered from the start of his jump at P before landing at Q. He's talking about horizontal distance. That's a tricky part. Do you remember in a projectile motion, there are always two components of everything. If this
Yes, the
is
vertical and the
velocity,
horizontal.
every component, everything has two components, horizontal velocity and vertical velocity. Horizontal velocity and vertical velocity. And he's talking about horizontal component. And he's talking about resultant velocity. That's a tricky part because he's not talking about vertical or horizontal velocity. He's talking about his speed v with the horizontal. So when you see this shape, it will first increase. When you are going up, will it increase or decrease? For the upward journey.
The distance will increase.
That's right. But velocity, will it increase? The object is initially going up.
So if we go up, it will decrease the velocity.
Yes. The first part of the journey, velocity will decrease. Now, technical question comes here. At the highest point here, will the x component still survive or everything will become zero?
The horizontal component will still be there.
Okay, that it means speed will not be zero. At the highest point, speed will not be zero. Am I right?
Yes, the y will become 0.
Vertical component, but he's not talking about vertical component. He's talking about overall component. So 2 points are clear. Initially, speed will decrease. Second, speed will never become zero. Speed will never become zero. Speed will never become zero. So can I say A and C are wrong?
Yes.
Why C is wrong?
Because it shows that it becomes 0 at the maximum position.
So which is not possible. A is wrong because it shows initially velocity increases. Now we are left with B and D. We are very similar, but the difference is there. B shows a straight line graph and D shows a curve. We have to select from them.
So D will be the answer.
Now, how we know? Do you remember the formula for velocity? V is equal to under root. Do you remember this formula?
No.
This is the formula for, it's a Pythagoras theorem actually. Resultant speed. This is the formula for the resultant speed of the projectile motion. Now, this is the formula for a resultant speed. You can see the equation. Now, it's a mathematical concept. If something is containing squares and root, will it be a straight line or will it be a curve?
Will be a curve.
Yes. Straight line is always a linear equation. A mass on the end of a spring bounces up and down as shown after being released at time is equal to 0. So this is a spring and we have some load attached with it. We have pulled the spring down and the load is here and we release. The spring will go, object will go up and down, and this is the mean position. Now, this is a memory from O level. When something is oscillating, what is its velocity at the mean position? Will it the max or 0? Mean position.
At mean position, it will be the maximum.
Yes, mean position velocity will be maximum. At the highest point, velocity will become 0. At the lowest point, velocity will also become 0. So I made a picture. He's making a displacement time graph and asking you to convert it into velocity time graph. Now the question comes, the object is moving up and down. The object is going down, going up. So do you think velocity should take negative sign also?
Yes, it will also take negative sign.
The object is going up and down. So should velocity take negative sign also?
Yes, because if it's the same case as the previous question,
Yes.
like
so if I take this, suppose this is plus, then this would be minus. So why I have cancelled D?
it doesn't show negative.
Good. The object is released after being released at O. This is the lowest position. So object is released at the lowest position. So now I have cancelled B. Why cancel B?
Because it starts from the bottom position.
And at the bottom position, if you look here, what is the velocity?
It's 0.
So now we have choices between A and C. A shows one complete cycle, and if you can look carefully, C shows two cycles. Now choice is there. Should I consider two cycles? You have to look at the source graph. How many cycles are shown by the source graph?
One.
Very good. Source graph shows one cycle. Number of cycles won't change. This shows one cycle and this shows two cycles. So that's why C is rejected. The velocity of a car changes as shown. What is the acceleration of the car? Be careful about unit conversion. Formula is simple. It should be 80 upon 20, but 80 should be converted. Twenty is fine, but 80 should be converted.
That gives 22 meters per second.
The final answer or
80 converted.
acha 22. Convert this 22 upon 20.
1.1.
A cannon fires a cannonball with an initial speed v at an angle alpha to the horizontal. This is a typical projectile question, and it is a type of derivation. So when you launch a projectile, you can resolve the velocity like this. At the highest point here, y component will become 0 and only the horizontal component will survive. He's talking about maximum height. When object is going upward, will the acceleration negative or positive?
Negative.
Very good. So I give this. Now you have to make a data. U is equal to V sine alpha. V is equal to 0. A is equal to minus G. S is equal to H is equal to question mark. Why I am not considering cos alpha? Can you tell me why cos alpha is not considered? Cos alpha is for horizontal motion or for vertical motion?
For the horizontal motion.
Yes. And what about G? gravitational acceleration, is it for vertical or horizontal?
Vertical.
Yes. So that is why I'm considering only this. As I always advise that this is MCQs are like a complete questions. So do working with me in writing. So that is the only way to get a grip.
So this will be C.
Yes. A skydiver falls vertically from a stationary balloon. She leaves the balloon at time t is equal to 0. At time t is equal to t, she reaches terminal velocity beyond the time shown in the graph. Beyond the time shown in the graph, she opens her parachute. So interestingly, he's drawing graph of force against time instead of velocity or acceleration. Is it right that force and acceleration are directly proportional?
Yes, F is equal to ma.
So it means when you draw a graph for force, you actually draw a graph for acceleration. So this is like that. So when from a stage, she leaves the balloon at time t, she reaches terminal velocity. When you reach terminal velocity, is it right that velocity is constant then?
Yes.
What about acceleration? When velocity becomes constant, acceleration becomes
0.
what about force?
Force will also be 0.
Very
Result.
good. Force should also be 0. So now you have to see beyond the time shown in the graph, she opens her parachute. He's talking about air resistance. Now this is a trap. Normally, a student will mark answer as D. Can you guess why many students would have marked it D?
Because it is also showing that the final is 0 and that it is
Yes.
that.
Final force is 0, but D is wrong. Why? This is the resultant force which becomes 0. And if you see carefully what he's connecting,
Resultant won't be 0 because of their resistance.
when an object reaches terminal velocity, this is the weight of the object and this is the air resistance. Can you tell me that at terminal velocity, when velocity becomes constant, acceleration becomes 0, resultant force becomes 0, will the air resistance become constant or it will keep on increasing?
Their resistance will increase.
How come? When resultant force is 0, this is the resultant force. When resultant force 0, will air resistance and weight should be equal?
So it will be constant.
This is the trap. This is the trap that resultant force becomes 0. it is possible that if I say suppose x at terminal velocity, x will be equal to w. So at the time of terminal velocity, the air resistance would be constant. It won't increase. It will remain equal to the weight. So what should be the answer?
So it'll be B now.
Yes, it is B. Why not A? A also shows constant velocity. The difference is a straight line. When it is a straight line, it means force is increasing at a constant rate. But this is not the case. Actually, force is proportional to acceleration. Acceleration does not increase at a constant rate when air resistance is present.
Without air resistance, the answer would be B, D.
Without air resistance, acceleration would be equal to G, which is not a case here. It is not equal to G. It should not be a straight line. Which state, a body is released from rest and falls vertically in air, falls vertically in air at a constant, air of constant density. Strange things get. Initial velocity is 0. Which statement about the motion of the falling body is correct? Always try to first locate the elimination approach.
A will be wrong.
A will be wrong because weight does not decrease. It accelerates initially at 9.8, but the drag force increases, so its acceleration decreases. Whenever something falls, initially its acceleration is 9.8, but the drag force increases. Air resistance increases until it balances the downward force. So B can be the answer. Its velocity increases at a constant rate until its velocity becomes constant.
Going down, the velocity increases.
That's fine. That's right. But the problem is this word, constant rate. What is the rate of change of velocity?
Acceleration.
Yes. So it means it is connecting here. When you say constant rate, does it mean constant acceleration?
Yes.
Yes, which is not the case. Acceleration is not equal to G when air resistance is present. So due to this error, C is wrong. Constant rate means constant acceleration. The drag force of the air increases continually and eventually the velocity decreases. What about D part?
The velocity will decrease, but I'm not sure about the drag force.
The drag force of air increases continually and eventually the velocity decreases. Why velocity should decrease? Velocity can reach terminal.
It will
That
become
is
constant.
right. And terminal velocity means constant velocity, but why velocity should decrease? Velocity will increase and it can become constant once terminal level is there. So this is wrong because velocity should not decrease. The diagram shows an arrangement to stop trains that are traveling too fast. Trains coming from the left travel at a speed of 50. At marker 1, the driver must apply the brake so that the train decelerates uniformly in order to pass marker 2 at no more than 10. The train carries a detector that notes the times when the train passes each marker when it apply an emergency brake if the time between passing marker 1 and marker 2 is less than 20 seconds. How far from marker 2 should marker 1 be placed?
We'll use an equation of motion for this one.
Yes, marker 1 is 50 and marker 2 is 10. Time is 20 seconds. So he's asking for the distance.
S is equal ut plus half at square will be used.
We use that.
But we don't have the acceleration.
I was thinking we should first find acceleration from this equation, but you're right that we don't have the distance. So we should use A is equal to A is equal to V minus U upon T. This will give us acceleration. And then we can use S is equal to UT plus half AT square. So we can do it in 2 steps.
The acceleration is coming as -2.
-2. Okay. Then put -2 in the second equation.
So 600 meters is coming by this.
600 meter. Oh, so then option would be D. A double-ended launching device fires 2 identical steel balls X and Y at exactly the same time. The diagram shows the initial velocities of the balls. They are both launched horizontally, but Y has greater speed. Y has greater speed. So it means they will, it looks like a projectile question because they will eventually follow a projectile path. I have hypothetically extended the graph. Both an X and Y reach the ground simultaneously because air resistance will cause both to have the same final speed.
This will be wrong.
Because air resistance cannot cause both to have the same speed. The problem is air resistance, this part. both x and y reach the ground simultaneously because gravitational acceleration, it is positive g here, it is positive g here. See, is very strange. X reaches the ground before y because X lands nearer to the launcher. Meaning of X. He means that X will travel less horizontal distance.
But the vertical will be same.
Vertical is same. So time should be same because they both are traveling the same vertical distance. So when vertical distance is the same, the time should be the same. Y reaching before X. This is wrong. Because vertical distance is same, so time would be the same. A is wrong because of this air resistance logic. Both objects have traveled the same vertical distance. Both objects have traveled the same vertical displacement. So they will reach the ground with the same time. Same together they will reach. So it means this should be the B should be the answer. So we have done some tricky questions today, and kinematics and dynamics are two very important topics. So we keep it up to here, and we will inshallah continue it in the next class. Allah Hafiz.
Allah Hafiz.
Acha, sorry, what topic can you do for me in the next class? Can you do dynamics?
Yes, I'm attempting the whole past paper, so there are many questions in there.
But the theory revision is required, na? So that's why I'm highlighting it. Okay, Allah Hafiz.